So yeah, we're currently looking at the forecast for tomorrow, and it looks like there's going to be some severe storms, especially just north of New York City. It appeared that there might be some storms here in northern New Jersey going into New York City, but it looks like this threat has shifted slightly further north according to the HRRR. However, the NAM 3KM, the high resolution NAM, is showing that there's going to be a pretty widespread area of severe weather in the Northeast. Doesn't look too widespread. So the 18Z does not show a very widespread area of severe weather. Let's look at the 12Z. So supercells, it's definitely showing supercells right here. Showing supercells, isolated supercells here, northern New Jersey. There's one right there. Showing southerly winds in New York. Right here, you're having a southerly flow with storms coming in out of the west. So let's look at surface winds because wind shear is paramount for tornadic development. So let's look at the surface winds. Not too strong. I mean, right here there's a little bit of a strong little surge there. Because the winds are kind of being funneled along the Jersey Shore into New York. But the winds here inland are about 50 to 25. Still, you could get an isolated tornado. There's definitely shear because you're getting storms are quickly moving from the west. So definitely there will be some shear tomorrow. So let's look at the Cape for tomorrow. Let's look at the how much convective energy it is going to be. So of course, you have sunset, but you're having all this humid air coming in. So some pretty high Cape. So let's look at soundings right now. Anyone can look at a map and color code maps, but a sounding is what they usually teach you in advanced met classes. Something I haven't done yet, but I'm trying to teach myself how to read soundings. So right here, this is your dry adiabatic lapse rate, and this is your moist adiabatic right here. Just very, very unstable air tomorrow. It's a lot of convection here, and then you would calculate the area in here using a formula I haven't been taught yet, so I'll probably meet one of my meteorology professors to try to see how that would calculate. Okay, this red line is your virtual temperature. The red line is your going to be your environmental or forecasted temperature. This green line is your dew point, and here are your temperatures, and these are your wind barbs. And these are showing the wind direction, 75 degree, showing a potential hazard type for tornadoes. Very weak potential. Sometimes this blue line represents basically percentages. So this is basically percent, how likely it is. If this would be up here, that's very concerning. Again, there is a tiny chance of EF3 tornadoes, but very, very unlikely. And I mean, this line means it means a very slim chance, basically. So there is a good chance of that if any tornadoes form, they'll most likely be EF0 to EF1, slight chance of a couple EF2s, but almost no chance of any EF3s or EF4. So, I mean, it's still possible, but very unlikely. And they're showing classic supercell signatures here. So, but it is humid here in the Northeast. Keep in mind that the humidity is going to be pretty high. So while there's going to be a chance of classic supercells, they'll most likely be high precipitation or HP supercells. So let's look at 2-meter dew point. This is looking at tomorrow afternoon. High 60s to a couple of low 70 dew points. So this is going to be a very humid air mass. And Sunday is going to be very humid as well, but no severe thunderstorms forecast for Sunday. So Sunday is just going to be very oppressive. No storms in the forecast. Saturday is going to be pretty stormy, but it's not going to bring any relief for Sunday. So again, let's look at 20Z. Let's look at Mid-Atlantic 20Z. So this will most likely be going up to 14Z. Yeah, 14Z. So now let's look at 18Z. That will be hour 20. So again, most of your storms are going to be north of the city. So it looks like Poughkeepsie might get some pretty strong storms extending down towards northern New Jersey. I mean, this is definitely up for change because 12Z, this is what the 12Z had. 12Z had a line of strong storms, not supercells, but just a line of strong thunderstorms moving through New York City. And then supercells again up here. So this is still entirely possible. I mean, we could get this line of gusty storms that moves through Saturday. Based on what I'm seeing right now, I believe this is what I believe is going to happen. I believe they may put in a slight area of enhanced for wind. It's going to be a wind-driven enhanced. I still believe the hail is going to be yellow, and they might potentially put a 5% in, but unlikely. But I think there will be a wind-driven enhanced in the lower Hudson Valley, central Pennsylvania, and I do believe that this enhanced, the slight risk, will be put a little further south. And here's why I believe this will happen. Because even though the marginal risk only goes down to just around the Atlantic City area, just a little bit north of Atlantic City, there are potentials for very strong storms. So here's what I think is going to happen tomorrow. I believe the area between marginal, slight, and enhanced is going to be very small, almost very tight cutoff. So you basically will have it. They may extend it further south, but I don't think they should. So I believe that even if they keep it up here, they may move the slight risk maybe a little further south, or keep it as is, or even move the slight a little further north of New York City, but put it enhanced in the central New York region into northern parts of the lower Hudson Valley, especially like Poughkeepsie. The reason I'm thinking this might happen is based on the current model guidance, but keep in mind that the 18Z runs are very unreliable. But again, see how they're showing storms down here? This could also push the thunderstorm threat further south. So basically, the entire Northeast needs to watch out tomorrow for strong to severe thunderstorms. Primary threat will be damaging winds. Secondary threat, also close to primary, should be large hail. But the number one threat will be damaging winds. Large hail, damaging winds, large hail, and a threat, just an isolated threat of a couple tornadoes. The highest threat should be, I believe, in northeastern Pennsylvania and central and southern New York, because that's where the winds will be strongest. That's where you'll have highest helicities. Because especially in the lower Hudson Valley, those winds could get funneled in between the the Berkshires to the east and the Catskills to the west. So you'll have a bit of a wind tunnel or a bit of a Vertucci effect. Not a very strong one, but you will have winds being funneled down the valley, and that will definitely enhance low level helicity. And if you have some upper level helicity, you could definitely get a weak tornado that will form. In fact, there was a supercell that back in 2020, just about a day and a half before um, Hurricane Isaias went up the coast and brought strong tropical storm force winds to New York City, a supercell formed right over my location in Poughkeepsie, moved northeast, and dropped a tornado in the northeastern part of the county. And I actually recorded the wall cloud. It was not the wall cloud, but the mesocyclone. It was rotating, and I actually videotaped it. It wasn't warned at the time, as it was very weak, but it did have thunder and lightning and have big drops of rain. Again, the conditions were very similar. You had southerly winds, and the storms were not coming in from the west, but they were actually coming in from the southwest. So there's actually more helicity. There's more potential for rotation on Saturday than that day, than August 1st. I believe it was August 1st, 2020 that happened. It was August 1st, 2020. So, storm reports 8/1/2020. So let's just check that. Yeah, see. There we go. Yeah, they saying it was August 1st. Yeah, so it was August 2nd. Guess I got the date confused. That's the tornado, I think. Then when did Isaias hit? Yeah, that's from Isaias right here. Yeah, so yeah, that was the day. And you had a tornado that went northeast, actually went into Columbia County after being near Ulster, and it dropped a tornado here. Yeah, there we go. No, there was actually a tornado in New York. It can't be right. There was actually a tornado in New York. I think Litchfield, Connecticut. Yeah, yeah, exactly. There was actually a tornado in far northeastern Columbia or Dutchess County. I'm not guess it went unreported, but there was a video of it, and I saw supercells. Frank, yeah, there was even enhanced here. And all that came was one tornado report, a couple wind reports, and then the very next day we had Isaias. Thought it was on the first that this happened. Could have sworn it was the first. Oh, there we go. Yeah, there's Isaias right here. '60. Yeah, there were thunderstorms the night before Isaias, some pretty strong thunderstorms. Yeah, right before a hurricane comes in, you get hail. Isn't that weird? And actually, there was rotation. I actually noticed some rotation, what could have been a debris signature that night, and it wasn't tornado warned. Let's see, New Jersey. And I did have some rotational eddies that came through, but they didn't drop any tornadoes. And they weren't warned, but it was definitely something to look at. All right. So let's look at now. We're gonna change gears and look at the sea surface temperatures. All right. All right. So Atlantic is very warm. I mean, it's not as warm as it was here just a few weeks ago, just a few days ago. I could show you an animation of how crazy it was. Yeah. So this is going to take about a minute to load. It's a little sluggy right now. Yeah, okay. Looks like it didn't load. There we go. All right. Right. It's taking so long. Looks like Coast Watch and NOAA that GOV is down. All right. Yeah, it's down. Just want to make sure my internet's on. It's working. All right. Just want to make sure. Yeah. It's weird. What? This is America. What in the world? There we go. Oh, so they forgot to update the website. Oh my God. Coast Watch. So basically, you got to be kidding me right now. Data. There we go. I think it's data portal map viewer. So yeah, they definitely changed it. All right. Sea surface temperature anomaly. There we go. Yes, there we go. I mean, I actually much rather have it be the way it was before. Yeah, this website is just ugh. This new website is just completely. I can't even like zoom in or zoom out properly. Oh my God. Unbelievable. Ah, there we go. SSD content shorts, I guess. Okay, let's. Yeah. Oh, there we go. Coral Reef Watch. Okay. Let's look at tropics. Actually, let's do global. I want to do a global. Okay. So they're not. Okay, 7 days. What happened to 30 days? What in the world? So temperature trend past 7 days. Ooh, look at that. It's cooling down a little bit. Maybe the El-Nino is starting to wane finally. All right. What in the world? Global. Wow. It's not good. A lot of coral bleaching. All right. That's not what I'm trying to do. I'm trying to do. This is for hurricane forecasting. What happened to the animation, 30-day animation? What happened to that? They got rid of it. Oh, right, right. This is a laptop. All right. Global. There we go. This is what I was looking for. Okay. So they said that there's been some cooling here. There has been indeed, but this is where you have some very, very warm waters. I haven't even looked at the National Snow Ice Data Center, Arctic ice, but yeah, very warm waters. It almost looks like there's a bit of a migration of warm waters moving northeast. Oh yeah, this is because of the crazy heat wave that Greece recently had. And look, a cold front moved through. Look how quickly the Mediterranean went from like 5 degrees Celsius above normal to below. You had crazy storms that moved through, severe weather, cold front moved through, and boom, cool, everything cools down. Yeah. No, but here, this. Ooh, the Northeast is going to get buried with snow. Wow. 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 Um, I mean, if this doesn't get too strong, if this can cool down a bit, and this can stay really warm, and this can stay really warm, oh, it's going to be a snow fest for New York City. Snow fest. It's going to be Northeast is going to get storm after storm after storm after storm, blizzard after blizzard. Yeah, because you're going to get a lot of, you're going to have a major Arctic outbreaks, especially these blocking patterns here. This is a very, this is a warm PDO. This is a warm phase of your PDO right here. And you're having a warm phase of the Atlantic simultaneously. This is also not good for climate change. This is bad. Really bad. I mean, yeah, You could get these simultaneously. Very, this happens about every 50, 60 years. But the last phase wasn't this warm. Keep in mind that each phase of each oscillation is getting warmer and warmer and warmer. This is also bad for California. Even though we're having an El Nino, this here will bring major ridging over the west, which means very little snowfall for the west coast. So all that rain they just got, that partially refilled Lake Mead and Lake Powell, and did a lot of good for California. Their reservoirs are basically full. In fact, they got too much rain, but they may go back into drought. California may have another drought by 2025 because of this. This is a very bad sign for California. All right, so while you're having an El Nino, it doesn't look to be as strong as anticipated. This actually may go. It looks like this El Nino may actually weaken a little bit now, because I'm seeing waters warming over here. Meaning there might be some more upwelling here soon. So, yeah, we're going to have a very snowy winter in the Northeast. Midwest is kind of open play. So, I don't know if you're watching. So, I don't know if you're watching me. What's your name? But very, very cold, snowy winters in store for the Northeast. And I know climate deniers are going to say, oh, climate change is a hoax, blah, 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 blah. Well, because the jet stream is weakening due to the temperature differential between the Arctic and the tropics getting smaller because of how quickly the Arctic is warming, the polar vortex, which is normally is supposed to be strong, is weakening. In fact, that's why we're getting so many bad cold outbreaks in the winter in the Northeast, especially in the plains in the South, because here you have all this land. Here you have a lot of land, so yeah. Also, another major determinant for how cold and snowy winter is going to be. This has been a trend that's been going back 40, 50 years, but it's been that trend, that signal has been losing its credit. It hasn't been having much of an effect the last couple of years because of climate change. Normally, when Siberia has a lot of snow in October, when you get a lot of snow in Siberia early in the winter or early in the fall, when you have above average snowfall in Siberia for the month of October, it actually increases the air pressure. You get more high pressure because of the cold. So you get an increase in high pressure. And that increase in high pressure here, you'll get an increase in high pressure. You would get breakdown of the polar vortex, which would lead to sudden stratospheric warming events and cold outbreaks into the Northeast, and less snow and precipitation for Siberia. However, if you get less snowfall than average, you get lower than average pressures here. This is what has been typical until like the last few years. But this did happen in 2014, 2015. But look at how warm the global ocean is. This is terrible. This is just catastrophic. But so you'll get more when you get less snowfall in October. This is according to Dr. Judah Cohen. This is something he noticed and made winter predictions on. You would get high or lower pressures, which would strengthen the polar vortex and keep more of the cold and snow further north. We had above average snowfall in October of 2019, pretty well above normal actually, but New York City had almost no snow. There was a reason for that. Right here, the Rycock volcano had a pretty strong eruption, and it sent a lot of sulfate aerosols into the northern latitudes, and this strengthened the polar vortex because the sulfate aerosols cooled down the Arctic more. And so you had a stronger polar vortex that kept a lot of the cold and snow out of the lower 48. The same thing happened in 1815 when Mount Tambora had its low end super eruption. The winter of 1815 into 1816 was mild. You had a mild winter, milder than average for that time. So people thought, oh, we're going to have a good spring and summer. But then all that Arctic air that was trapped there for an entire winter, plus enhanced by less sunlight reaching the Earth because of the eruption, the Earth was already cooler as a whole, and it just flooded down into the lower latitudes around May and June. New York City had snow in June. Savannah, Georgia had rain 46 degrees in August. I mean, also you had significantly less sunlight reaching the earth because of the sulfate aerosols, but also you likely had a big decrease in ozone layer. So, because at the time we did not know that sulfate aerosols, just like carbon fluorocarbons, deplete the ozone layer. But it definitely strengthened the polar vortex in the winter of 1815 into 1816, but the summer was very cold. That is why New York City had quote unquote record breaking snowfall on May 9th. This was not because of global cooling. The earth is indeed warming, but it was because of that volcanic eruption. It was a small one. It was only a VEI of 4, but had a lot of sulfate aerosols. In fact, let's look at global temperatures right now. This is actually going to be the website of a climate denier named Dr. Roy Spencer, who believes that climate change is natural. Well, just what is going on now is natural, and that you have fluctuations in temperature. So let's go to global temperature anomalies. August. Yeah, this is the type in July 2023. It's called "What's Up with That." I've been going to his site for years, always to disprove his theories. I've been like, I was kind of hoping he was right, but I realized no. Oh, August. What happened to August? What happened to July? There was July 2023 that was right there. Clearly showed records. Jeez. I might have to. Maybe I'll find it in his site. All right. All right. Oh, yeah. Let's go to July. July. Come on. Because he had July there. Underscore 2023. All right. Let's look at July. There we go. July. Come on. There's no July? It was just there. Great. He got rid of it. Son of a gun. But yeah, we were like up here. It was 0.62. It's about right about there. We definitely are going to break records this year. Oh, yeah. This is the 1998 El-Nino here, which was over Celsius. But this line was down here just a few months last year. They increased the averages. They do that every few years. Because new averages come in. Everything is becoming warmer. I mean, look at this. Don't look at the 13-month. Look at the long term. Everything is just going up, 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 up. Look at the long-term trend right here. So it almost look like it's increasing exponentially, increasing slowly at first, and then look, watch this. Almost like it wants to increase exponentially. Oh yeah, we had an El Nino, a La Nina, a triple dip La Nina, and guess what? Oh yeah, we barely were below this, and before that we were above that new line because they keep on increasing they keep on making this bigger and making this, yeah. So basically, yeah, solar activity. Even though we still had a pretty strong solar minimum, actually this minimum was slightly more significant than the last one, and it had almost no effect on global temperatures, no decrease. So the idea that, oh, solar minimum is going to cause global cooling, BS, complete BS. In fact, we're having some pretty intense solar activity right now. And now they're going to say, oh, that's why we're having record temperatures, because we're having normal sunspot activity. So keep in mind that they were claiming this is why we're having colder than normal temperatures. No. You see this here and here? Look, solar cycle 25 is stronger than normal. So Gazprom was wrong. There was a Russian scientist that was funded by Gazprom who said, "Get your fur coats. We're going to have an ice age." Well, guess what? You're wrong. We're not. We're going to have instead climate change, aka global warming. We can say climate change all we want because one or two areas of the world are getting colder. But the truth is, the world is warming very, very fast. Not faster than anticipated because of some global browning, some slight global dimming from soot and aerosols, but we've decreased that. So we've actually slightly decreased the albedo effect. We haven't had a major volcanic eruption that has emitted a lot of sulfur since 1991, even though the Hunga Tonga eruption was slightly larger than the Pinatubo eruption. It was underwater. So it emitted huge amounts of water vapor, which is going to make the climate change issue worse. It's going to exacerbate our issue even more. And yes, it emitted sulfur as well, but also vast quantities of water vapor. And hydrocarbons. So if you apply the name, it's not just carbon dioxide. There's also a hydrogen component in our emissions of CO2. Hydrocarbons. Hydrofluorocarbons, while not as dangerous to the ozone layer as chlorofluorocarbons, are worse for climate change. Water vapor is one of the most intense greenhouse gases out there, much, much more intense than carbon dioxide. It's about a factor of 100, just so you should know. And the amount of water vapor that Hunga Tonga emitted into the atmosphere is a pretty big amount, but not enough to make a significant impact on what we're doing to the planet. We're making a more significant impact than Mother Nature. So basically, we are making a much bigger impact. And here is why. So imagine, this is what my professor taught me when I was studying at Stony Brook. Imagine you're depositing money into account. Every day you deposit $100, or every year you deposit $1 million, and you take approximately a million back. Every once in a while you maybe take 990,000 out, maybe take $1,010,000 out, or $1,010,000 out. Very close to the level. So any fluctuations are small. But then imagine you put in $1 million, take out $1 million, but then a friend of yours is adding 10,000 every year. Very small at first, but then after a certain amount of time, it starts to increase. So every day he adds 10,000, 10,000, 10,000, 10,000, 10,000. So you put in a million, take out a million. So, right? But then now those small increases are not being deducted. So those small increases just snowball. We are that little needle that pushed the delicate system over the edge. While it's true nature emits more CO2 than we do, nature also takes it out. So technically, are we so once you factor that out, we are actually emitting more because we're not taking anything back. We're emitting, and that's it. So, or should we say, we are basically not undermining our effect. We're not undoing, we're not compensating for what we're putting in. Not to mention the deforestation. So here's how we're adding more CO2 through deforestation and emitting CO2. So we're almost everything we do adds CO2 to the atmosphere. And the cattle industry emits a lot of methane. So you understand where this is coming from. Climate change is a very serious threat. It's already a threat now, not just for the future, but now. Seems like my stream froze. All right. Oh, you gotta be kidding me. All right. Back now. So it looks like okay. So thankfully it wasn't like what I was thinking. All right. So let's again look at the sea surface temperature anomalies. This hurricane season will likely be above average, and the forecast for this winter looks to be for the Northeast at the very least very tumultuous. Major snowstorms on the East Coast, especially inland areas, because you see how there's fluctuation that's getting much above normal then slightly less above normal, but the trend is looking like we're going to have a very, very intense winter, especially for the northern United States and the Northeast. But I'm worried about the West Coast, as I said earlier, because of drought. Um, oh, yeah. So while the primary focus of this live stream was to focus on severe weather and hurricane season, I'm also going off on tangents to talk about the winter forecast. But again, the primary focus is to talk about the winter season. I mean, the hurricane forecast. So let's go to Spaghetti Models, which has the National Hurricane Center outlooks. And also, but I prefer using tropical tidbits. But at the moment, no tropical systems. Well, no outlook for tropical systems as of yet. But then what is that? Area of showers and thunderstorms. So let's go to tropicaltidbits.com and look to satellite looper. Let's go to satellite imagery. Hurricane Dora is still active in the Pacific, and it might actually become a typhoon as it heads into the Western Pacific. Dora is still a hurricane. Would you look at that? Oh, look at that! Dora is about to become a typhoon. We're this close to getting a typhoon. Look at that. Ooh. Yeah, we're about to get typhoon. Look at the 2023 Pacific typhoons. Okay. We're about to get we are this close to getting Typhoon Dora. There we go. There we go. On August 11th at 21 UTC, Category 2 Pacific, Typhoon Dora. Hurricane / Typhoon Dora. I thought they were gonna change it to the Eastern system, the Western name. Alrighty. Oh well, look at that. Very strong typhoon, right? Not anymore. It actually doesn't look very strong. Yeah, you don't have a central dense overcast anymore. That CDO is gone. It's shredded. I mean, yeah, there's an eye wall here, but let's look in there. Yeah. And look at that upper level low. Yeah, that's why the system is being pulled northwest. And look at that trough moving in here. Oh yeah. This is going right towards Tokyo. Yeah, this is heading right towards Tokyo. Typhoon Dora. Let's see, Dora. Let's see what Typhoon Dora is going to do. So it's just considered a regular typhoon. So category 1, category 2 is considered typhoon. High end 2 to moderate 3 is consideration. They don't go by category 1, 2, 3, 4, 5. So strong cat 2 to low end cat 3 is considered very strong typhoon, and anything that is high end cat 3 and above is considered a violent typhoon. Yeah, there's also a super typhoon. South of Midway Island. Yeah. So yeah, look at that. It has not crossed the international date line yet. So oh yeah, it has. Because 180. Yeah, it's not 180. Yeah, it has crossed the international date line. So even though it's in the western area, it's already considered a typhoon. All right. Well, it's no longer a hurricane now. Oh, how is it going to be 25 degrees north? Oh yeah, you have cooler waters. If it continues going west, let's say. All right. All right. Let's look at. Yeah. Let's look at this here. All right. So let's look here. So definitely a lot of convection here, but you're getting a lot of storms right now in Georgia. Wow. Yeah, those are some very strong storms right now. And it looks like most of those storms are showing. You know what's so funny? As crazy intense as it looks on on the satellite imagery, those storms aren't actually very strong. There's an outflow boundary, and you're getting storm formation. It looks like, yeah. Let's look at this right now. The most crazy thing is this is actually the more intense storm here. There actually is some pretty strong winds with these storms here. Of about, let's see, about 50 miles per hour. Yeah, from that here. Wow. That storm is special marine warned. That's causing those bursts there. Those storms are special marine warned from that cluster. And I believe it's warned for water spouts because I'm definitely spotting some areas of rotation. And yet, no, just for winds in excess of 35 knots. Normally it's 34 knots, but they said 35 knots this time. Wow, so many hail reports right now in Minneapolis. Wow. Okay, I'm gonna go to radar scope on here. I don't have pro. Come on. Radar scope. Come on. Didn't I download radar scope here? The heck? I had radar scope on my phone. Didn't I download radar scope on my laptop? What happened to it? Heck? I downloaded radar scope here. How did it just? Oh man. Anyway, severe thunderstorm warning for the Minneapolis St. Paul area. Storm just went through Minneapolis. The storm is warned for quarter size hail. Not winds. It's just warned for quarter size hail. Source radar indicated. These storms are producing large hail. Seek shelter now inside a certain structure. Stay away from windows. And then the threat, it says hail threat radar indicated max hail size 1 inch. Wind threat radar indicated max wind gusts under 50 miles per hour. Okay. Um, yeah, and Let's see what the largest report. The like literally downtown Minneapolis just had actually. You know what? Um, let's go to Twitter because I want to show you guys what's going on right now. Even though I cannot show you on Radar Scope. How about I'm gonna go on Twitter.com. Yeah, and it's gonna be X. Of course, X. Elon Musk is such a ugh. Greta Thunberg is so much better than that loser. MNWX. Yeah, Gladiator. Yeah, him and his transphobia, him and his. At least he's not a climate denier. But still, I wouldn't be surprised if he becomes one. Not Minneapolis. Wow. You're in the updraft. And all that down there? See that? Oh, that's where your heavy rain is. So like, where's the updraft? So hail is basically being thrown at rain in the area of heavy rain towards where you are. Let's go to the latest. Oh yeah, that is not quarter size hail. That's about golf ball sized hail. Oh, that's golf ball. Yep. Oh yeah, tennis ball sized hail. They reissued the warning for golf ball sized hail, 60-mile-per-hour wind gusts. Not surprised. Downtown Minneapolis. Yeah. I think I just heard my abusive stepfather call me.
My car. It's pretty fucking loud. Not really under the fucking overpass. Under 35 here. On 26th Street. On 35 going south. Getting smoked by.
Lucky, nice. Just slightly, just near quarter-sized hail. It's a quarter to dollar-sized hail. Oh, it's Dylan. Oh, hey, I'm doing a live stream. Yeah. All right. Bye. Thank you. So it wasn't my step.